one of the things to know about a 45, 45, 90, okay, obviously there's the 90 degrees, so that means the other two are 45 degrees, and with two angles being the same, that makes this an isosceles right triangle. So if you have an isosceles right triangle, then your angles are 45, 45, 90, guaranteed. I'm going to show you where these ratios, or this ratio comes from, and then we're going to use the ratio to find missing sides. Okay? The nice thing about these is with the Pythagorean theorem, we can only find one missing side. You have to have 2 out of the 3 in order to use it. But with these ratios, we only have to have 1 out of the 3, and we can find the other 2. So when you're going and looking at these problems with the right triangles, the first thing you should look at is, do I have 2 out of 3 sides? Then you're going to go for the Pythagorean theorem. But if you have 1 out of 3, you're going to be using this. Okay? So we're going to say, well, if both of these are the same, then our legs of our right triangle, we're going to call them both, we're just going to say, what if they had a length of 1? Okay? If they had a length of 1, we're going to see what C should end up being. So if we do C squared equals A squared plus B squared, then we have C squared equals 1 squared plus 1 squared. So C squared is 1 plus 1, which is 2. Taking the square roots of each side, C is the square root of 2. Okay, so the nice thing about a special right triangle, 45, 45, 90, is if both of these sides are congruent, then to get the third side, it is simply the leg times the square root of 2, because you could put a 1 in front of this, and you would get 1 square root of 2, right? Which is just square root of 2. So in a special right, 45, 45, 90, the ratio is 1, 1, square root of 2. Now, in order to make it more useful, because we're going to use this with numbers other than 1, okay, we're going to say all of our special rights that are 45, 45, 90, the legs, we're going to call them x, and we just said a moment ago, to find the hypotenuse, you multiplied by the square root of 2, so the hypotenuse is going to be x square root of 2. This is a ratio that you want to remember. Okay, so put a circle around it or make it visible. You're going to come back to this. So one of the first examples that we're going to look at is if we know that our hypotenuse, well, if we know that a leg is 9, okay, then usually what I recommend is pick a variable. You can use S, I think, which is typically what the book uses, but S is not always that great because sometimes it looks like a 5, and you don't want to mistake it for a 5. All right, I'm just going to use X, but it can be any variable. So inside the two legs, we're going to take those ratios and actually write them inside. So we have x, 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 square root of 2. What this allows me to do is figure out what x is, and then I can plug it in anywhere else that I see an x. So right over here, we know that x should be 9. So over here, this side length should also be 9, right? And what would my hypotenuse have to be? 9 radical 2. Okay, those are the easy ones. If you find x first, the rest of them are pretty easy. You're just going to attach the radical 2, basically. Okay. So let's look at another example, because they're not all that easy. All right, with this one, they are calling this x. So if they're using x as something that you're going to find, then I would maybe use a different variable, right? So let's go with a. So we'll call this a, which means that's a, which means this is a square root of 2. Okay, so in this case, we know that a is 2 radical 2, which means that this side up here should be the same. So this should be 2 radical 2. So we're going to take that value of a and plug it in here. So it means we still have to multiply by radical 2. All right, so if we drop this down, we have 2 radical 2 times radical 2. And if you remember back to algebra, you want to keep things in simplest form as long as you can. So you're going to multiply the 2 radicals. Radical 2 by itself is just 2. So this would be 2 times 2. Okay, that's what we got from the 2 radicals, which would be 4. Okay, so x would have to be 4 in this case. All right, still not too bad, but sometimes you have to divide out the radical because they give you a whole number for the hypotenuse, okay? That's why I recommend you still set them up this way. So the next example, here's our 45, 45, 90, and they give us 6, and we need to find x. Okay, now if this were 6 radical 2, that would be really easy because you would just take off the radical 2. But when there's no radical 2 to divide out, we're still going to say, okay, this is x, x, and x radical 2. So you start with the equation that you have, basically. Okay, so x radical 2 equals 6. Now, if I had, and this goes back to your algebra, if I had 2x equals 6, what would I do with that? Divide out 2. Well, instead, I want to get rid of radical 2. So I'm still going to divide out radical 2. And just so you don't miss that step when you look at your notes, I'm going to add it in, but you don't have to add a second step. You can divide automatically. Okay, but just so you can see how I got from here to here, I'm dividing out the radical 2, which is going to leave me with x. The problem is, if you remember back to algebra, you can't leave a radical in the denominator of a fraction. Does anyone remember how to get rid of it? Yeah. Close. You're going to multiply. Well, the only thing, we can't square it because we'd have to square both sides. And you don't want to square both sides because that's going to give you x squared. And we want to keep x. But the only thing that you can do to something and not change it is multiply by a form of 1. So in order to get rid of the radical on the bottom, remember we used that radical and say, okay, well, we're going to multiply by that radical over itself because that is a form of 1. It won't change our fraction. It'll just put it in a different form. It's like turning 1/2 to 2/4. Okay. So on top, I would get 6 radical 2. On the bottom, I get 2. And is that totally simplified? The radical's okay. You never divide a radical by a whole number, but 6 over 2 does simplify to 3. So we're going to make that 3 radical 2. So each of my sides should be 3 radical 2. This is another section that's all dealing with simplified radicals. You shouldn't have any decimal answers unless it says round to the nearest tenth. All right.